Welcome back. Now let us start doing the hands-on with file 2.4 image underscore OpenCV underscore contours dot py. So please open this file. So this is the file. Please open it in Spider. And this one is going to be a bit more challenging in terms of learning. Definitely it will give you the good amount of learning, plus you will see a lot of the applications are based on this. So this is one of the basic building block for image analysis and for image processing, and it is a building block of many computer vision tasks. So let us go ahead and do it. So line number 1 to line number 13, we know what it is doing. Okay. And first of all, if this question comes, what is the contours? And what is the meaning of contours? So it is equivalent to, let me show you through one image. This was the image has been drawn by me. So for this diagram, contours means all the boundary points when you take it and connect. That is a kind of contours. And in case of circle, we have seen this is called perimeter. And this is true for any kind of image. Even for this one, if you see this like this and so on. So even for this one, it's contours. Okay, for any kind of image, not necessarily it's open or closed. In case of open, it is a bit different thing that I will explain as we go ahead. Okay, so what are the why we need this? First of all, if you want to do any kind of first of all, if for any object, it gives you the boundary and shape of it, plus how many points which are connecting it, and it also helps a lot in the image analysis. Okay, so object detection and recognition, there is a very good example of contours. So definitely it helps in the shape analysis and object detection and recognition. The prerequisite is that it needs the binary image. Binary image, meaning of it black and white. And most of the OpenCV functions, they modify the image you give. So you should give either copy or keep the original copy intact in other variables so that you have the original copy. Good. And whenever we see this binary image, we need white object from black background. It means the background should be black and the front should be in the white. Okay, so now let us start. Just have little bit patience for this chapter, because this is a little bit of hard working chapter. It means you need to be a bit you need to have a little bit of patience, and then you will realize the benefit of it. Okay. So in line 25, we are reading this arrow.png. This is the thing, because it will help us to understand the various shapes of the image. Okay, and line 26 we are converting to gray, and line 27 we are just showing it. So this is what it looks like. Let me close this image. But one thing, if you say, we had said that we need the black background and white foreground, but this image is having just opposite. So we need to do the converse. So we need to do the opposite of it. Okay, but okay. Now, if you remember in the past chapter, how we have done it, we had used the threshold and which we did the inverse of it. But threshold, if you see, how do we get the threshold? We had got through the proper histogram. Now I'm showing you another way to get the cutoff value. Okay, so this is the one histogram. This is there in OpenCV. This takes the image. This is the number of channels. Since we have gray, so number of channels is 0. Okay, mask none, it means we want the full image as it is. Bin count, that is the full scale we want, and range 2 to 256. This is the things. Let us see how does it gives. Okay, so if you see what it is giving you, that this image is having almost some good amount of pixel concentrated at the highest, and the rest is this almost binary. So you can take any cutoff of around 200 or so. Okay, 200 or so. So we have taken this 200 from here. You can 210, 220 both are equally, those are right. So 200 is the cutoff, and we are doing the taking threshold binary inverse. So what is the meaning of binary inverse? See, first of all, let me show you what is the meaning of binary inverse. Binary inverse is, let me show you first the output, then you will understand. See, we are having the image first. I'm trying to run 27 again just to see that image. So the foreground which you see, this looks like a bit black, okay, this black, and we want this as a white and remaining everything as a background as a black. Okay, now let me run this one and see the output. So if you see this, that foreground wherever we had that is white and everything has become black. So black means what? Black means color equal to 0. Okay, so what it did with this one, in case of inverse binary, all the before less than 200, that was the 0 things, that has become white, and opposite of it. Greater than 200, that is the white part has become 0. That is why if you see this black, this background has become almost black. It is a fully black, okay, except that few of the image boundary. This is how we have to do it. So if you're trying to find it out contours of any image, and that is not there in this this shape, that is a black background and white foreground, then please convert it first. Please bring it to this stage. Then only you can find the contours onto that. Okay. So this is the prerequisite till this point, and we'll start finding the contours in the next video. Thanks a lot for watching it. See you in the next one.